Imagine this for a moment. You're standing at a hotel and checking out after holiday. You hand over your payment card. The terminal beeps. Your payment is approved. Everything feels completely normal. Now, here is the question. What made that bank trust its CO card? Was it the plastic, the magnetic stripe, or something else entirely? For many years, the entire card industry it relied on surprisingly very simple idea. If the payment card data look valid, the card is probably genuine. That approach helped the payment card industry grow around the world. It was fast, practical, as well as it was very much efficient. But there was one problem. The weakness wasn't obvious, and customers couldn't see it. Even merchant couldn't see it. Even most of the people working in the banking industry never thought about it. Yet that hidden weakness eventually became so serious that the payment industry made one of the biggest technology migration in its history. Banks replaced billions of cards. Even merchant upgraded millions of payment terminals. Even the payment network introduced new technical foundations. And the familiar magnetic stripe slowly gave way to EMV chip. So what went so wrong that replacing almost every payment card in the world became so better option? Hello and welcome back to the Payment Blueprint. In this episode, we are going to uncover the hidden security problem that forced the industry to reinvent the payment card. And this story begins with a simple assumption. So let's go back how typical card payment worked before EMV. Imagine you are shopping a new laptop. You swipe your magnetic stripe card, and within a couple of seconds, the payment is approved, which is straightforward, simple. But what actually happens behind the scene? The answer is shown on the slide, on the right hand side. The card contained payment information on its magnetic stripe, things like card number, expiry date, as well as service code. The payment terminals read that information and passes it to the authorization process. From there, the issuer evaluates the transaction using that information together along with the authorization and fraud controls. And for many years, that approach worked amazingly well. It was fast, it was even reliable, and perhaps most importantly, it could be used by millions of merchants and banks around the world. That is why the card payment grew so quickly. Now, here's the assumption that entire model is dependent on. If the payment data look valid, then the presented card could appear genuine. That doesn't mean that every transaction was automatically approved. Banks still applied their normal authorization rules, available balance checks, even spending limits and fraud controls. But the payment itself began with one of the important assumptions. The data being presented belonged to the genuine card. For several years, the assumption seemed perfectly reasonable, until one simple question changed everything. What if someone copied the payment data without even stealing the card itself? And that's exactly where the story takes us next. Okay? Everything we have talked about on the previous slide is dependent on one assumption. The payment data belonged to a genuine card. And for years, that seems perfectly reasonable. But here's the problem. The magnetic stripe wasn't storing information that changed every time you made a payment. Much of the core payment data stayed the same. You could use the card to check into a hotel, check in into a hotel, or you can buy a ticket next week, or maybe you are paying at the airport the following month. The places changed, the merchants changed, the amount changed, but much of the information, which was read from the magnetic stripe, it remained the same. Now think about what that means. If someone managed to capture the payment data, they didn't necessarily need the original card anymore. That's exactly what this diagram is showing. The genuine card is at the top. Its payment data is read. If the card data is read, it can exist independently of the physical card. It can then be written into another magnetic stripe. And the result is that the card you can see at the bottom, a counterfeit card. And here is the part that many people misunderstand. The criminal didn't create another bank. They didn't copy the customer's money. They simply reproduced the payment data that the original card had been presented all along. And once that became possible, the payment industry faced a completely new question. If two different cards could present exactly the same payment data, how could the bank tell which one is actually genuine? That's the challenge we are going to tackle next. Now we have reached at the real problem. Imagine two cards being used at the different places. One is genuine card and the other is counterfeit card which is created using the copied payment data. From outside world, They are completely different piece of plastic. But that's not what the payment system sees. The payment system sees the information on the card itself. Let's follow the two journeys. On the left, the genuine card is used at the payment terminal. The terminal reads the payment data and sends it for authorization. Everything is exactly as expected. Now look at the right hand side. The counterfeit card presents the same copied payment data. The terminal doesn't know it's looking at the counterfeit card. It simply reads the information that has been presented and forwards it to the authorization system, just as it could do with any other magnetic stripe card. So the issuer receives the payment data that appears to be very much familiar. The account may still be active, the card number may be valid, even the customer may have the available funds. The issuer can still apply its normal authorization and fraud controls. But there is one question the payment data alone cannot answer. Did this information come from the original card, or is the card copy or duplicate? That's a trust problem. The data could look genuine, the card presenting it might not be, and that changes the challenge completely. The industry has no longer needed a better way to read the payment data. It needed a better way for the card itself to prove that it was genuine. And that's exactly the problem EMV was designed to solve. Once the industry understood the real problem, the obvious question was, why not just add more security information to the magnetic stripe? At first, that sounds like a sensible solution. If criminals could copy the existing data, why not simply store more data? But that wouldn't solve the real problem. Because if the new information stayed the same every time the card was used, it could eventually be copied as well. The industry wasn't running out of the information. It was relying on the same proof over and over and banks also became much better at monitoring transactions. They could even spot the unusual spending patterns or unexpected locations or maybe unexpected behavior that didn't match the customer. Those checks were valuable and still they are today. But notice where those control sets. They work around the card. They don't change how the card proves that it's a genuine. And that's the difference shown on the slide. Old approach was simple. The card presented the same payment data. The terminal reads it and the system trusted it. And the cycle is repeated now and then. The industry needed to break that cycle. And instead of presenting the same proof every time, the card needed to contribute something new to every new transactions. Something that couldn't be copied and reused later. And that was the breakthrough. The security model itself had to change. And once the industry reached that conclusion, EMV was no longer just another improvement. It became an entirely different way of establishing trust. This is where everything changed. The payments industry stopped asking, can we trust this payment data? Instead of that, it started asking, can this card prove that it's really a genuine card? The single shift changed the entire security model. Now look at the comparison. On the left, the magnetic stripe followed the predictable pattern. The card presented the same reusable payment data. The terminal reads it, and the same information could potentially be presented again and again in another transactions. Now look at the right hand side. EMV takes completely different approach. Instead of simply presenting the stored information, the chip became an active participant in this entire payment lifecycle. As the transaction takes place, the card and the terminal exchange information. The chip uses the information from the card together with the details of the transactions to produce the security that it's linked to the specific payment. Now, think about what that means. Imagine you are using a card to pay for a hotel tonight, and tomorrow you can use the same card to buy a train ticket. It's still the same card, but the security evidence created for those two payments are no longer exactly the same. Each transaction has its own context, and the chip contributed to that transaction. That is why simply capturing information from one EMV payment doesn't automatically provide equivalent proof in the next one. And that's the real breakthrough. EMV doesn't just replaces the magnetic stripe with a chip. It changes how the trust is established. The card is no longer just presenting the payment data. It's actively helping prove that it's a genuine card. That one idea made counterfeit magnetic stripe dramatically more difficult in EMV chip card present environment. But here is something important. Making one type of fraud is much harder doesn't mean that fraud disappears. It simply forces criminals to look for other opportunities. And that's exactly what happened next. By this point, The industry finally had a better security model. But there was one more challenge. The payment card never worked on its own. Every payment card involves multiple organizations: the card, the payment terminals, merchants, processors, even the payment network, and also the important piece, which is the cardholder bank. If even one of that couldn't support EMV, the entire payment journey would break. And that's why replacing the magnetic stripe with chip was never going to be enough. Entire payment systems had to move further. Bank had to issue new EMV chip card. Merchants had to upgrade millions of payment terminals. Even acquirers and processors have to support the new EMV transaction data. Payment network even had to introduce new rules and infrastructure which are needed to make those transactions work consistently across the world. And all of those organizations have to move in the same direction. Different countries migrated at different speed, depending on their payment infrastructure as well as the local priorities. That's why EMB wasn't simply just putting a new payment card. It became one of the largest coordinated technology migration in the payment industry. Because changing how a card establishes trust means changing almost every organization involved in the payment processing. And once that migration was underway, the counterfeit magnetic stripe fraud it became significantly harder. But something else happened that very few people expected. Fraud didn't disappear, it evolved. So, did EMB solve the problem? Yes and no. It solved the specific problem the industry had set out to solve. Using copied magnetic stripe data was no longer enough to create the same level of trust in an EMB chip based card present scenarios. As a result, the counterfeit card fraud became significantly more difficult in an EMB environment. Criminals don't stop attacking simply because one door has been closed. They look for another one, and that's exactly what happened. Instead of concentrating on cloning the physical card, many attackers gradually shifted towards areas where EMV was never designed to provide protection. Online payments, social engineering, or there are other scenarios like account takeover or credential theft. In other words, the target changed. The attackers adapted, and the payments industry had to adapt as well. That is why EMV should never be described as a technology that ended the payment fraud. Instead, it changed the economics of one of the industry's biggest fraud problem. But the payment security is continuous journey. As criminals evolve, security has to evolve with them. And that's a lesson that still applies today. So now we know why the payment industry reinvented the card. We discovered that the real problem wasn't the plastic. It wasn't even the magnetic stripe itself. It was the way payment card established the trust. And EMV changed that forever. But here's something interesting. We have spent this entire episode talking about why EMV was needed, without even really explaining what EMV actually is. Most people may point out to the little golden chip and say, oh, that's an EMV. Well, not quite. The chip is only the visible part. The real story is everything which is happening behind it. Who actually defines the rule? How does the card know what has to say to the terminal? Or how do both sides understand each other without human interventions? And how does all of that eventually becomes a part of ISO 8583 authorization message that actually reaches your bank? That's exactly where we are going next. In episode 2, we will move beyond the chip itself and uncover the framework that makes EMV work across billions of payment cards, even millions of payment terminals around the world. If you enjoyed this episode, I would really appreciate your support. Please like the video, subscribe to the Payment Blueprint, and turn on the notifications so that you don't miss the next episode. Until then, keep learning, stay curious, and I will see you in episode 2.